Hello, Mr. Munyon here with lesson 19-2 on geometric mean. So in the last lesson, we learned that we could use, when we have an altitude of a right triangle, that we could use similar triangles, proportions, and right triangles to be able to solve for some unknown pieces. In this lesson, we're going to learn how we can use what's called a geometric mean to be able to basically solve for some of those pieces a little bit faster. So first, what is a geometric mean? There's a problem here we're going to skip. We're going to first focus on what a geometric mean is. So most of you guys are probably familiar with what an algebraic mean is. If I take two numbers like 3 plus 7, add them together and divide by 2, I would get 5. So I averaged 3 and 7. That's halfway between 3 and 7. That's an arithmetic mean. A geometric mean is when you multiply two numbers together. So let's say that we have some numbers like 9 and 4. Okay, if I multiply them together and then take the square root, what happens there? So 9 times 4 is 36. And the square root of 36 is 6. This is called a geometric mean. So instead of adding numbers together and dividing by however many numbers that you added, a geometric mean is when you take two numbers and multiply them together and then take the square root. So then let's look at the corollaries that it had up there at the top about geometric mean. All right. The first one says that when an altitude is drawn to the hypotenuse of a right triangle, so let's say we have this example here that is an altitude drawn on a right triangle, the length of the altitude is the geometric mean between the segments of the hypotenuse. So that value t, which is the altitude, is going to be the geometric mean of the two pieces of the hypotenuse of the big triangle. So without looking at anything else on this page, if I just look at this first corollary, I know that t is going to equal the geometric mean of x and z. This is a much more convenient way as opposed to having to draw out the similar figures. You got 3 different triangles. I recognize here that looking at let's say you wanted to solve for t. T is the long leg of the smallest triangle. That corresponds to the long leg of the medium triangle. I could get a proportion here. And then if I do the ratio of the short legs, x on the small triangle is the short leg, and on the medium triangle, t. So x over t. If I wanted to solve for t, I could multiply both sides by t. So t goes over here. And on the other side, it cancels out. And then multiply both sides by z. You get t times t equals x times z, or t squared equals x times z. Take the square root, we get t equals square root of xz. Hey, look, that's the exact same thing that we just got over here. This was much shorter. It just said t is the geometric mean of x and z. It's a shortcut. We could redraw all of our triangles, figure out which pieces correspond, set up and solve, but that took, a minute and a half or so, whereas just writing down the geometric mean took maybe 10 seconds. So this is the most important one, and that's usually the easiest one to identify for most students. Whenever you are looking at you're trying to solve for the altitude, and you happen to know the two pieces of the hypotenuse, that one is just easier to remember for most students. T is going to be the geometric mean of the two pieces of the hypotenuse, x and z. There is another corollary 2, when the altitude is drawn to the hypotenuse, so this red line I have up there, of a right triangle, each leg is the geometric mean. So let's look at this long leg. W is going to be the geometric mean of something. Between the hypotenuse, so the whole hypotenuse of the big triangle, and the part of the hypotenuse that's adjacent to the leg. So only the part of the hypotenuse that's adjacent to this leg up here, so z. So w is the geometric mean between the hypotenuse P and the part of the hypotenuse that's there, that's adjacent to it, so z. On the other side, this leg, u, is the geometric mean between P and the part that's adjacent, x. All right, so this one is a little bit harder to recognize for students, but it's also just a shortcut. Would we be able to solve for these pieces using similar figures, doing Pythagorean theorem, setting up proportions, and solving like we did in the last activity? Yeah, we could do that, but these are just a little bit shortcuts. So let's practice these two corollaries. Obviously, the pictures help, so the ones that we kind of just drew here, the diagram at the top is important. If you didn't screenshot and take those down in your notes, do that now. Go back, rewind a little bit and go back and do that, because otherwise we're just going to practice with these a little bit. All right. Okay. Oh, we have an example here. I'm not going to go through this one because obviously it's just another example. It goes through step by step. Let's get to a problem that we can do. Okay, so now we have the picture here we can use as well. So it says in the figure in example A, this is the figure over here from example A, use the corollaries above to solve. So if y equals 2 and x equals 16, then determine z and show your work. So this is the piece we're solving for. I know that the first corollary says when you draw an altitude, that altitude is the geometric mean of the two pieces of the hypotenuse, y and z. Okay, so now we'll just plug in the pieces. X is 16, y is 2, and z is what we're solving for. Okay, so we can square both sides. So 16 squared is 256. And when you square it, cancel that square root, you're left with 2z. Divide by 2 and you get 128. And so we have solved for this one, and we do get 128. If you multiply by 8 to get the other leg, we should be able to take the short leg here and multiply by 8 to get the long leg, and that is what you get. So 128. All right, let's try the next one. I'm going to go ahead and erase this here. So if x equals 18, z equals 45, determine y. That's the piece we're looking for there. Show our work. This is the same corollary. We've got our altitude, and then we've got the two pieces of the hypotenuse. So the x is going to be the geometric mean of y and z again, and plug in our pieces. 18 equals the geometric mean of y and 45. So then square both sides. And we get positive 324. And then divide both sides by 45. I'm going to need a calculator for this one. And we get 7.2. And that does look like a reasonable answer. It's a little bit more than twice as much. So if this was 7.2, twice as much as 14.4. So more than that, twice as much as 36. It looks like, 2.5 times as much for these. So it does make sense, our answer. It is reasonable without having to go back and check using the other methods. So y equals 7.2. All right, so let's practice the other corollary as well. Okay, 5 is basically exactly like what we did. So pause here, see what you get for 5. I'll put your answer in a second. You can try 6. It's actually 3 different problems. Let's go ahead and go over number 7 now, and then I'll go back and do the other ones. All right, so it says, explain how to use the two corollaries we learned in this lesson to find Pj. Well, first, let's look at what pieces we have. I do have an altitude drawn. The second corollary says that when you have an altitude drawn, one of the legs is going to be the geometric mean of the entire hypotenuse and the part of the hypotenuse that's adjacent to that leg. So 15 is going to be the geometric mean of 34 and NJ. So let's go ahead and solve that one. Square both sides. And then divide both sides by 34. All right, and on this one, the exact answer, I'm going to leave as 225 over 34. So NJ, 225 over 34. And the approximate answer I got was about 6.62. But because I'm going to use it again, I'll use the exact answer here as opposed to plugging in the approximate answer with rounded. So we get about 6.62. Now that I know that one, 34 minus 6.62 is going to be 27.38. Use the segment addition postulate. 34 minus 6.62 is about 27.38. And now that I know these two pieces, I could use the first corollary to solve for this one. Remember that the altitude x here is going to be the geometric mean of the two pieces of the hypotenuse. So this one is even kind of oriented like the three other examples that we did, the two that I did, and if you've already done number 5. I'm not going to solve that one, but when I put the answers, I'll have that one on there as well. So let's check our answers then. All right, so here are the answers for 5 and 6. Hopefully 5 was really straightforward. 6, same thing you were solving for t, the altitude, you just do the geometric mean. For B and C, I went ahead and showed the work over here on the right. So B is in red and C is in blue right here. And then I did put the answer that I mentioned I was going to for this one. Obviously, go through the work if you needed the help. On the lesson practice, same thing. I'm not going to go over these anymore because it's one of the two corollaries, but I'll put the answers here as well. All right, so here are your answers to check. If you got stuck on one of these, I'll give you a hint. Use one of the two corollaries. I don't think you needed to use Pythagorean theorem. I didn't use Pythagorean theorem on any of these. All right, if you were overwhelmed with this lesson, but you felt good with 19-1, I would recommend, they may take a little bit longer, but you can do all of these problems using similar triangles, redrawing each of your 3 similar triangles, setting up proportions, or doing Pythagorean theorem. All right, guys, I will see you on the next lesson. Good luck.